So today we're going to talk about rational exponents, and we're going to simplify expressions that have rational exponents. So there's two forms that we have, radical form and exponential form. So radical form means it's in radicals, so radical 36. Exponential form means that instead of having a radical, we're writing it as an exponent. So the square root of 36, in exponential form, we would have 36 to the 1/2. Okay, so that's coming from the exponent and the index. The 36 has an exponent of 1. The index is a 2. So we're taking the exponent and dividing it by the index. So for the cubed root of 64, that would be 64 to the 1/3. And for the fourth root of 16, we would have 16 to the 1/4. Fractional exponents will still follow the laws of exponents. So everything that we know about the properties of exponents, how when we multiply we add them, when we divide we subtract them, when we raise to a power we multiply them. Same rules apply if they're fractions instead of whole numbers. So we want to find the simplest form of each expression. So 64 to the 1/2. We could write this as the square root of 64. So you should be able to go from radical form to exponential form and from exponential form to radical form. So 64 to the 1/2 would be the square root of 64. And I know that that is 8, so we've simplified it as much as we can. Now 11 to the 1/2 times 11 to the 1/2. You can do this one of two ways. So we could rewrite them both as square roots. So square root of 11 times square root of 11. Well, we know that would be the square root of 121, which is 11. So 11 is my simplified answer. Another way to get it, since the bases are the same, since I have 11s as my bases and I'm multiplying, I can add my exponents. So I would end up with 11 to the 2/2, which would just be 11 to the first power, which would be 11. So I get the same answer either way. Now with the next one, 3 to the 1/2 times 12 to the 1/2, we can rewrite them as square root of 3 times the square root of 12, multiply them, get the square root of 36, and end up with 6. Right? The other way you could do it is because they have the same exponent, you can multiply the numbers. So 3 times 12 raised to that exponent. So again, we have 36 to the 1/2 power, which would be the square root of 36, which equals 6. So I'm just showing a couple of different ways that you can get the same answer. Okay, so if we look at these ones, so 49 to the 1/2, and that would be the square root of 49, which is 7. 2 to the 1/2 times 32 to the 1/2. I can multiply 2 and 32, and I get 64 to the 1/2, which is the square root of 64, which is 8. Okay, now 3 to the 1/4 times 27 to the 1/4. So 3 times 27 is going to be 81 to the 1/4. So if I want to rewrite that, that's going to be the fourth root of 81. So my exponent was 1, the index is 4, and now I'm just going to break this down. So if you need to use your trees, go ahead. So 9 and 9, 3 and 3, and 3 and 3. We're looking for groups of 4 of the same number. So here's a group of 4. So 3 would be our answer. So here's a key concept that if you have a number raised to an exponent that's a fraction, okay, we talked about this before a little bit, that the top number is your exponent, the bottom number is your index. So if we want to find the expressions w to the negative 5/8, so we're going to do that one first. So w to the negative 5/8. If we want to write that in radical form, well, the first thing, same rule applies with exponents as with rational exponents. You can't have a negative exponent. So if I have a negative 5/8, that has to get rewritten as 1 over w to the positive 5/8. It's the same idea that's going to the bottom. Now we're going to rewrite this as 1 over. Now the exponent is the 5. The index is the 8. Since we know that we can't have radicals in our denominator, we have to rationalize it. Since the exponent is a 5, I need to make it an 8 so I can divide 8 with 8 and cancel out the radicals. So what I'm missing then would be the 8th root of w cubed. So you want to think about what does that exponent have to be, so that way if you add it to the other exponent, you'll end up with the index number. So now when we multiply across, we have the 8th root of w to the 3rd on the top, and now on the bottom, we'll have the 8th root of w to the 8th, which is just going to end up being w. Okay, now with w to the 0.2, it's best to always change things into fractions. So w to the 0.2 is the same thing as w to the 1/5, which would be the 5th root of w to the 1st. And we're done. Okay, so what are the expressions? The 4th root of x cubed. So that one, remember, the exponent is the numerator, the index is the denominator. So x to the 3/4. And then, even if you have parentheses, it's the same idea. The 4 is going to be your numerator, the 5 is going to be your denominator. Okay, so we want to just convert these into the proper form. So radical form or exponential form. So if it's in radical form, we're changing it to exponential. If it's in exponential, we're changing it to radical. So the cubed root of a squared, we'll have a to the 2/3. X to the 1/5. 1 is your exponent, 5 is your index. T to the negative 3/4. So that is like the other example. So we have to make it 1 over t to the positive 3/4 first. Then we rewrite it as a radical. So the 4 is the index, 3 is the exponent. We can't have radicals in the bottom, so we need to multiply. Since the exponent is a 3 on the bottom and we need it to be a 4, we need to multiply the top and bottom by just the 4th root of t. So now we got the 4th root of t on the top, and on the bottom we'll have the 4th root of t to the 4th, which reduces to, or simplifies to t. Okay, so 7x to the 3rd and now this whole thing is getting raised to the 1/2. So we need to be careful there because the 7 is in the square root as well. So basically we have 7 to the 1/2 and x to the 3/2. Okay, and then in the next example, since the 5xy is all getting raised to the 6th, we can write this as 5xy to the 6/3. So 6/3 is just going to be 2. So we have 5xy squared. And then we can actually square each piece. So 25 x squared, y squared. Okay, and then for the last one, we have 1.2. And remember, we want to change decimals to fractions. So this would be y to the 6/5. And then when we go to write it, 6 is our exponent, and 5 is our index. And we can actually simplify this because 6 is greater than 5. So we can rewrite this as the 5th root of y to the 5th and the 5th root of y. So then the 5th root of y to the 5th just becomes y, and then we have the 5th root of y left over. Okay, so all of the exponent properties apply to rational exponents. So I know I mentioned this before, but again, it's important to remember. So these are just a list of all the different properties and how there's an example with the rational exponents. So when you multiply, you add. When you raise to a power, you multiply. When you divide, you subtract. If you have a negative, it goes to the bottom. So let's look at this first example. We want to find the product of radical 3 times the 4th root of 3. So we can't multiply them because the indexes are not the same. But what we can do is rewrite them. So instead of the square root of 3, we can write that as 3 to the 1/2. Instead of the 4th root of 3, we can write that as 3 to the 1/4. So now that we've rewritten it, we have the same base. So the 3's are the same, so we can add the exponents. So 3 to the 1/2 plus 1/4. So when we add 1/2 with 1/4, that's going to give us 3 to the 3/4. Okay, so that could be an answer in itself. If you wanted to continue with it and write it as the 4th root of 3 cubed, you could rewrite this as the 4th root of 27. So both are acceptable answers. Okay, if I will, on a test or quiz, let you know if it needs to be in radical form or in exponential form. Okay, and the second one, we are dividing. So we can't write them as one giant radical since the indexes are different. So we're going to simplify the top and the bottom. So first we're just going to rewrite the top as x to the 3/2. And we're going to rewrite the bottom as x to the 2/3. Since the bases are the same, they're both x, we're going to subtract. So x to the 3/2 minus 2/3. So when we subtract, we need to have common denominators. So this is going to be like x to the 9/6 minus 4/6. So we'll get x to the 5/6. Okay, and in the last example, again, let's rewrite them. So 7 to the 1/2 times 7 to the 1/3. So the bases are the same, so we're going to have 7 to the 1/2 plus 1/3. So again, common denominators. So we're going to have 7 to the 3/6 plus 2/6. So 7 to the 5/6. And if you wanted to rewrite it, you could rewrite it as the 6th root of 7 to the 5th. And then you can actually do 7 to the 5th. So 16807. Okay, so both would be acceptable answers.